Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Today I would like to present about usage and demand of water for water supply and wastewater engineering. Welcome back to our class DCC 40152 water supply and wastewater engineering. Okay, for chapter 2, the topic is usage and demand of water supply. Alright, okay, after finish this lesson, students are able to cover the classification of water demand. Okay, describe the classification of water usage following the domestic, commercial, industry, agriculture and public and non-revenue water. Okay, student also able to determine the population growth estimation and determine the formula for water demand forecasting. Okay, let me share the slide first. Okay, chapter 2 is usage and demand of water supply. Okay, first we look to the classification of water demand. Okay, classification of water usage is divided to six type is which is domestic, commercial, industrial, agriculture, public and non-revenue water. Okay, for domestic, normally we use for drinking, bath, cooking and washing. Actually, for water usage for domestic water demand. Okay, water requirement for domestic purpose are about 50% of the total water requirement per capita per day. Okay, and domestic use include water requirement for drinking water, bath, cleaning, sanitary and outside the dwelling. For example, for cleaning, irrigation garden, okay, field pond and swimming pool and wash car. Okay, domestic water demand also is purpose depend on climate factor, social status, quality and quantities for water. Okay, cost of water, water pressure, sanitary system and water supply type. Okay, water demand for commercial. Okay, for commercial water demand. Okay, for example, using for hotel, laundry, store, school and each. Okay, commercial water demand basically is a water supply to business, district and trains such as shop and office. Okay, for commercial water demand, this is include business which involve hotel, laundry, restaurant, stable and dairy each. Okay, for a town having moderate facility of hotels, laundry, stable and dairies. Okay, for commercial water demand also, the demand for commercial water is an average value is about 15 to 25 liter per capita per day. This is for assuming. Alright, classification of water demand for agriculture or for industry. Okay, basically for industry we use for fabricating, processing, washing, dilute, cooling or transporting and product. Okay, for industrial, we the water required depend mainly on the type of industrial in the town. The water required by factories. Okay, for example, paper mills, textile, sugar, and come for under industrial use lah. Okay, for a city with moderate intensity of factory, the water requirement may be taken 20 to 25% of the capital. 20 to 25% for capital per day allowance of the water. Okay, next for agriculture use. Okay, normally for agriculture use is for farmer irrigation. Okay, most of the water for irrigation is taken direct from river or borehole or tube well, because it does not need to be treated. Okay, and for water demand for public, okay, normally for public usage is for public utility. Okay, for example, sprinkling of the roads, cleaning for sewer, water for public parks and garden. Okay, the water required for road washing, okay, firefighting, sanitation purpose. It is for in big city. Okay, road are generally washed daily by municipality. Okay, water also required for cleaning public block and large market are included in sanitation purpose. Okay, for non-revenue water, okay, all the water purpose in all the water supply into water main does not reach the consumer. Okay, for example, some portion of the water is lost. Okay, some water of the the portion of water in the pipeline is lost due to pipeline or the joint of pipe. Okay, for example, the problem is come from pipe crack. Okay, pipe crack, or some water is also lost due to illegal connection. This is the normal problem where the consumer make the illegal connection for the pipeline. Okay, this is what we call non-revenue water. Okay, physical loss, for example, leaking, pipe leaking. Okay, commercial loss for because of thief of metering inaccurate. Alright. Okay, population growth for estimation. Okay, population growth for estimation is birth rate, mortality rate, and migration rate. Okay, there are three factors affecting the population growth. Okay, first is birth rate. Second one is mortality rate, and third is migration rate. Okay, for birth rate, the amount of people born into a city has a impact on a population. Okay, for developed country, then to have a low birth rate due to the ability of birth control. Okay, education and more women working outside the home. Okay, this is one of the most factor affecting the population growth in town. Okay, and for mortality rate, the amount of people dying in comparison to those being born is a factor in determining population growth rates. This factor is affected by other factors such as disease and purchase in a population region, war and healthcare availability, food resources and sanitation. Okay, developed country have better healthcare as or underdeveloped area, which is have a few healthcare resources. Okay, for migration rate, the amount of individual who migrate to a particular area will increase population. Okay, the migration is appeal of the region or by immigration factor the drive people for one area and into the other area. Okay, to calculate the population or to estimate the further population, we use two methods. Okay, to calculate the population or when we to estimate the further population. Okay, we use two methods to estimate. Okay, first method is arithmetic increase method. Second method is geometric increase method. Okay, for arithmetic increase method, this method based on the assumption that the population is increasing at the constant rate. Okay, the rate of change of population with time constant. Okay, for arithmetic increase method. Okay, this method to estimate further population, the population after n decade can be determined by this formula. As you can see, this is the formula we use for arithmetic increase method. Okay, Pn equal to P plus N multiplied by C. Okay, P is population at present, N is number of decade. Okay, number of decade is 10 years. Decade is for 10 years. C is constant for average or average of increase increase the decade. Okay, see how we get the C is dP over dt. dP is total of dP over dt. dP is for total of population. dt is total of decade. Okay, this is formula we using to estimate further population by arithmetic increase method. Okay. For a geometric increase method, we use this formula. As we can see, this is the formula of geometric increase method for estimate further population. Okay, this method or geometric increase method is based on the assumption that the percent increasing in population for decade remains constant. This method is different, okay, with arithmetic increase method. Okay, geometric increase method. Normally we use to determine the average percentage of growth of the few decade. Okay, the population at the end of end decade is calculated by this formula. As you can see, this is the formula we use for geometric increase method. Pn is equal P plus 1 multiplied by Ig over 100. Okay, P is population at the present. Ig is average percentage of growth on decade. Okay, this formula is very important, and normally we use this two method of we use these two method to estimate the further population. Alright. Okay, to get the more and understand. Okay, for your information, this is the formula for arithmetic increase method. Pn equal to P plus N multiplied C. Okay. Next we go take a look the example. Okay, we first we look to the arithmetic increase method example. Okay, this is, as we can see, this is the example for last 2 or 3 semester, the final exam questions. Okay, from this question, okay, the following data have been noted from the Kansas department. Okay, find the probability population in the year 1990, 2000 and 2010. As you can see from this question is for decade. Okay, the year we take a look, this is the year for about the decade. Okay, 1 decade, 2 decade and 3 decade from 1990, okay, 2000 and 2010. Okay, this question is give you the decade and the population. Okay, in 1990, okay, the total of population is 8,000. Okay, 1960, 12,000. Okay, 1970, 70,000. 1980 is 22,000 and 500. Okay. The solution of this example. Okay, first step. Okay, how we calculate the or how we estimate the further population using this arithmetic increase method. Okay, firstly or first step, okay, we must calculate the increasing in a population. Okay, we calculate the increases in population. Okay, how to calculate the increase in population? Okay, first, as you can see, this is row. Okay, first row is no. Okay, no value. Okay, no value. Okay, for the second row, okay, how to get this value is the population after 10 decade, we divide to the population the last decade. Okay, 12,000 population divide to 800, we get the 4,000. Okay, for the next increase in population. Okay, next step is you use the same step. Okay, 17,000. Okay, 17,000. Okay, and for the second row is 5,000. How we get the 5,000? If 5,000, all right, 5,000. Okay, first you is 5,000. Okay, 5,000 we get from 17,000 divide to 12,000, and for 5,500 is from 22,500 divide to 70,000. Okay, this is the increasing in population. Okay, and then after that, the next step is calculate the average increase. Okay, average inverse get from dp over dt. Okay, dp over dt, but we must calculate the total of increasing in population first. Okay, calculate the total increasing in population first. Okay, 4,000 plus 5,000 plus 500 and 5,000. Okay, equal to 14,500. And then calculate the we can calculate the average increase. Okay, average inverse. Okay, C is average inverse. How to calculate the average inverse is dp over dt. Okay, dp is total increase in population. Okay, divide dt is decade. Okay, the total of decade. Total of decade is n. Okay, one decade is 10 years. Okay. Okay, dp over dt is equal to 14,500 divide to 3. Okay, we get the value is 4,833. Okay, this is the how we get the average inverse or C. Okay, and then for the next step is we use this formula. Okay, we use this formula or arithmetic increase method. Pn equal P plus N multiplied by C. C is average inverse. Okay. The probability population is Pn. Okay, equal to P plus N multiplied by C. Okay, we use this formula to get the probable population. Okay. Okay, for the next step is we must develop this table. Okay, develop this table. This is table 1 and this is table 2. Table 2 is for calculate the estimate for the population. Okay, using this formula. How we calculate this value? Okay, you just put the value in this formula. Okay, first Okay, we take a look this question. Okay, this question wants you to find the probable population in year 1990, 2000 and 2010. Okay, this table 2, okay, is different from the table 1. Okay, table 1, the decade year is 1950, 1960, 1970 and 1980. Okay, for table 2, okay, we develop table 2, okay, based on the question. Okay, based on this question. Okay, this question wants you calculate for 1990, okay, 2000 and 2010. Okay, for the total decade is this question is 3. Okay, 1 decade, 2 decade and 3 decade. Okay. Okay, when you put the value in this, okay, in this formula, you can get this value. Okay, for example, for year of 1990, okay, the P is 2000, 22,500. Okay, where we get from this value. Okay, this value is P is the total of population. Okay, population in population of the year before. Okay, the year before. Okay, the decade. Okay, not the year but the decade. Okay, the population of the decade before is before 1990 is 1980. Okay, the population is equal to 22,500. Okay, that's why in this row the P value is 22,500. Okay, you put this value from this table. Okay, get to 22,500. Okay, plus n is for year. Okay, for year 1990 is 1 decade. Okay, okay, for year 2000 is 2 decade and for 2010 is 3 decade. Okay, this is must different value. Okay, okay, this value on n decade is must different. Okay, of this row lah. Okay, and then C is from the table 1 that we calculate first. Okay, C is in average inverse. Okay, average inverse. Okay, okay, finally, okay, after we put this value in this formula, okay, we can get the probable population. Okay, the step is the value that we put in this formula is the same. Okay, refer to the decade. Okay, this is the how to calculate how we estimate the further estimation of population. Okay, by using arithmetic increase method. Okay, for the next method is geometric increasing method. Okay, the step, okay, actually the step is quite same. Okay, but as we can see from this formula, geometric increase method, the difference between geometric increase method and arithmetic increase method is at this part. Okay, at this part. Okay, for arithmetic increase method that we have calculate before. Okay, the difference of between these two method is for geometric increasing method is we calculate the percentage. Okay, we calculate the by the percentage. Okay, this is the formula that we are using. KPN equal P plus P multiply by IG over 100 over 100 IG over 100 or IG divided by 100 is for to get the percentage. Okay, so we'll take a look the this example or example 2. Okay, the following data have been noted from the cases department. Okay, find the probable population in the year 1990, 2000 and 2010. Actually, this question is we use the same question for geometric increase method, same to the arithmetic increase method, but the step is different to calculate the by using geometric increase method. Okay, so first step to calculate the further to estimate the further population using by geometric increase method is, okay, first we must calculate the percentage increase in population. Okay, we use the same step in geometric increase method to calculate the increase of population. Okay, that we calculate before. Okay, increase of population, how we get the value of increase of population. Okay, how we get this value 4,000. Okay, this is the we using the same step to arithmetic increase method. Okay, increase of population, how we get this value is 4,000. Increase of population is for the year 1950 is no increase of population, but for the next decade have the increase of population. Okay, the value is from 12,000. Okay, divide to 8,000. Okay, is equal to 4,000. And for year 1970 is 70,000 divided to 12,000. That's why we get the 5,000. And then for year 1980, okay, 22,500 divided to, oh no, 22,500 minus, okay, minus to 70,000. Okay, we get the 500 and 5,500. Okay, increasing of population, how we get this increase of population? Actually, we get from population. Okay, the population of population. Okay, the population year after. Okay, minus. Okay, minus to population, the total of population the year before. Okay, that's why we get 4,000. Okay, 12,000. Okay, minus to 800 and equal to 400. Okay, increase of population for 1970. Okay, 70,000. Okay, minus to 12,000 equal to 500. And increase of population for year 1980. Okay, 22,500 minus to 70,000 is equal to 500, and 5,000. Okay. And then for the next step is calculate the percentage in population. This is the main step for geometric increase method. Okay, we calculate the percentage increase in population. How we calculate the percentage increase in population? Okay, for year 1950 is no value. Okay, no value because because the this is for the first decade. Okay, for the first decade. Okay. Okay, for the next decade, okay, 1960. Okay, we can calculate the percentage increase in population. Okay, we can calculate the percentage increase population by using this step. Okay, how we calculate the percentage in population? Okay, first, okay, increase the value of increased population in the same years. Okay, divide to population the year or the decade before. Okay, 4,000 divide to 8,000. Okay, the increasing of population in the 1960 divide to population in year 1950. Okay, as we can see this. Okay, 4,000 divide to 8,000 to calculate the percentage increase in population, and okay, multiplied by 100 to get the value of percentage. Okay, 4,000 divide to 8,000. Okay, multiply by 100. This we can get the 50%. Okay, for in 1917. Okay, in 1917. Okay, we use the same step. Okay, we use the same step. Okay, 1917. Okay, the percentage. Okay, the percentage increase in population 5,000. Okay, 5,000 divide to the population decade before. Okay, 5,000 divide to 12,000 multiply by 100 equal to 41.7%. Okay, the same step you can use to calculate the percentage increase the population for year 1980. Okay, 5,500 divide to 70,000. Okay, 5,500 divide to 17,000. Okay, multiply by 100 is equal to 32.4%. Okay, so this is the step how we calculate the percentage increase in population. And then the next step is we must calculate the average per decade. Okay, average per decade is total. Calculate is the value is from the total of percentage in population 50%. Okay, plus 41.7% plus 32.4%. Okay, the total of percentage increase in population is equal to 124.1%. Okay, this is the total of percent increase in population. Okay, to get the value of average in average per decade is total of increase in population divide to 3. Okay, how we get this value? Okay, 3. 3 is refer to the total of decade. Okay, the total of decade or the value of n. Okay, so how we calculate the total, how we calculate the n value is, okay, see, this is the decade. Okay, okay, 1960, 1970 and 1980 is refer to 3 decade. Okay, 3 decade. Okay, 124.1% is divide to 3. Okay, or n value is equal to 41.37%. Okay, this is the value of average per decade. Okay, after this step, okay, after we get the average per decade, okay, we use this formula, okay, using geometric increase method. Pn equal P plus P, okay, multiply Ig, divide 100, okay, to calculate the population or percentage using using geometric increase method. Okay, the step is very simple and so easy. Okay, this is the second table that you must write. Okay, for refer to the year or the decade that in question. Okay, in question, find the problem population in the year of 1990, 2000 and 2010. Okay, for this is the step is same step, uh, same step with the arithmetic increase method. Okay, but we use the different formula. Okay, for 1990, okay, for 1990, for year 1990, okay, okay, we put the all the value in this formula. Okay, P is equal to total of population in year before. Okay, in year before 1990 is 1980. Okay, is 22,500 plus P. P is 22,500. Okay, 22,000 P. The population, okay, the value of population in year before 1980. Okay, okay, I repeat, P is 22,500. Value is from the population year before year of 1990 is 1980. Okay, that's why we use the population, the value of population is 22,500. Okay, and then okay, P plus P, okay, 22,500, okay, multiply by Ig. Okay, Ig, this is the value. Ig is average per decade that we has calculate before. Okay, the value is 41.37%. Okay, so we just put the Ig value, okay, 41.70% divide to 100, and then the expected population in 1990 we get the 31,800. Okay, by using the same step, we calculate the year for 2000, okay, or the next decade. Okay, 1990, the next decade is 2000. Okay, the value of, okay, the value of P in 2000 is the P or the population the year before. Okay, that before I said the P value is the population of the year before. Okay, for 2000 the year before is 1990. Okay, that's why we use the value of P is 31,800. 31,800 plus 31,800, okay, multiply by IG. IG we use the same value, okay, the same value from this table. Okay, 41.37%. Okay, divide 400. Okay, we get the value of 31,800 plus 31,800, okay, multiplied 41.37 divide 100 is equal to 49,935. Okay, and then okay, for expected population in year 2010, okay, we use the same step. Okay, we use the same step. Okay, use the population, the value of population the year before. Okay, the year before 2010 is 2000. Okay, 49,935 plus 49,935. Okay, multiply by 41.37 divide by 100 is equal to 68,000 and 524. Okay, this is the step how we get the how we estimate the further population, okay, by using geometric increase method. Okay, this is the two method, okay, to estimate how we estimate the further population. Okay, so we finish. Okay, we has finished the two method. Okay, the method that to estimate for the population, the basic, okay, the basic method to calculate the further population. Okay, as we can see, this is the question for tutorial. Okay, for tutorial, I want all of you, okay, by using, okay, the table below show the population of people in Kuching City based on a record for Kuching Water Board. Okay, I want all of you calculate the population of people in Kuching City in year 2012 and 2020 by using geometric method. Okay, this is the table, the year and the population. Okay, this tutorial, okay, this tutorial I give all of you 1 week to submit this tutorial. Alright. Okay, so that's all for chapter 2, using the demand of water in water supply and wastewater engineering. Okay, so that's all for this chapter, and thank you.